Hello and welcome to the MATLAB programming for computational techniques. This is and at here we got error of length length order. So we just length for length. We have given this raw vector also. Given the vector error, we got defined error with a blank matrix and we label x-axis with the step size and y label is labeled with error. Hold on to hold the graph. Let's save it and try to run. Okay, so we got a figure like this. At here you can see the error is labeled with y-axis and the step size labeled with x-axis, and as the step size increases the error also got increases by the equality of step sizes. So for further more accurate or more good um, so yes, I want not to plot the linear plot. Actually, I want to log plot. So put a command log over here and just run. So as you can see over here, we got a log plot over here for the different lines, three different lines for the three different lines for the three different functions or the elements. Let us just close this and we use the legend over here. Legend n equal to 1 n equal to 2 and n equal to 3. So what this function will going to do that this function will align the every line with n equal to 1, n equal to 2 and n equal to 3 for the given plot. This is line number 1, line number 2 and line number 3 over here. And let's just show the graph. SSW. Okay, this is SHG. Show the graph, and as you can see over here, that we got aligned line number 1 with n equal to 1, line number 2 with n equal to 2, line number 3 with n equal to 3 for a logarithm graph. Let us look, let's put a marker over here for line number 2 also. Okay, so let me tell you a fact that these three lines are look alike collinear or the same slope, but it doesn't have same slope. It has some different slope for every 4 points. It has a different slope for every point, and it has also the different slope for every point. We will find it out that how much it will affect us when we draw not a logarithm graph but actually a log 10 error graph. So let us just clear the screen first. Let me take you to the example. Plotting over here and plot log 10 error graph and log 10 AOL. We might also have to put a figure over here. Figure 2 and SHG. So we are not delete this over here and try to run this. Okay, so we basically put a plot over here of log error and AOL. For that particular, you can see that we had got a, a 4 point over here. The first point is as we increases the step sizes, the error is also going to increases by respective of the step sizes. Okay, so when we just take the two elements like 1 plus a, the error is the order of a n equal to 1, so a is square. Okay, so a will be a to the power 2. The error would be the order of 2 order, second order. When we just put a first order um, expression of that particular Maclaurin series, as we further increased by the order or the order of the particular series, the error will also got ordered by 1 plus. Okay, plus 1 got error. Okay, so what we get a conclusion over here, we got a conclusion that more number of terms get us the lower error in the particular expansion. The smaller of a will get us the lower error in that expansion. The logarithm error and the log a um, takes us to a linear rise. Slope is basically the n plus 1, which I'm going to show you the next lecture. And slope is nothing but the order of accuracy of that particular series. By this, we come to the end of this chapter. See you in the next lecture. Till then, bye bye. Module 2. Let's start. So this is the lecture number 2.2 of module 2. In this particular module, we will cover the first kind of errors which we got through. So over 8 here, we have to define the exp val. We define this term also. Let us define it here. Exp val is going to come sum of terms. This term should be keep over here, and this should be. So what this term will giving us, this particular command will give us the Maclaurin series for one an element by element addition of each particular element. Okay, so we have not added one also. Let's put one also here. This is exp val of 1 plus a square by 2 factorial plus a cube over 3 factorial and so on, a to the power n upon n factorial. This is true value for the 0.1 exponent. Error will also represented by as the same, and just let's save it and run it. Let's try to put this over here. So let's try to find out the exponential value. So as you can see, we got the previous data is just like similar to exp val also. Let's try to find out the error. As you can see, the error is like 0.052 for the each individual term over here. Let's try to do another some programming over here. So as you all know, the error will for the yeah, what would happen at here if we reduce the n or the h over here. So let's do again this, do that. at Maclaurin series, and let's do it for 0.01. So a should be 0.01 over here, and exp value also should be not exponent 0.01 but a. Okay, so let's save it and then run it. What will we get? Okay, error. So as you can see, as we decrease the edge, and so the error is also going to decrease quite significantly over here. You can see this is a kind of error the reduced error we got in as we reduce the edge. So let us also define for the let's clear this screen and let's also call the edit Maclaurin. Let us do this for three terms, and let's just define a all c all to put we'll define it with 0.01 comma 0.05 0.02 over here. Now what we are going to do, we have going to do plot the graph between the error and the series. So define the error function also. We'll define it with an null matrix. So over here we have to define a all also. For I is equal to 1 to length of a all let's put an end over here. Let's plot a graph between error and the vector. We will define the vector. So let us also take this into this and make it to end over here. The major mistake we have done is define with add also. Okay, and a is equal to a all comma I, and we have to put we will put a graph between error and a all. Let's label the x-axis, x label with um, step size and y label with error. Let's hold on this graph also, and let's just see. This is the changes which we have to done for plotting the graph between error and AOL for the numerous element which we have chosen for our particular answer. Let's So we have got an error also here. The error is invalid expression. We're calling a function of index variable we parentheses. Okay. Okay. So we have don't defined it. Okay. Now run it. For I is equals to 1 to L and okay, so they defined it. Let me go to again MATLAB and at in that particular term device we can use vector times vector, or we just simply put a better way to compute is comprod vec. So yes, what will just going to be happen at here? This particular device this particular term will give me a square a1 and the or the and the n terms of Maclaurin series. So let me first just show to you how this will work. So let me give a is equal to 0.1 over here, and let's define the vac. Vac is equal to 1, 2 and 3. Okay, so what is going to be vac is basically, so we should not define, actually it's a mistake. Let's create the screen first. Define a is equal to 0.1 over here, and let's see how the vac command will work. Okay, so it is like 1, 2 and 3 over here. Let me show. Oh, it is not. And we got an error. Why we got an error? Because we did not give a equality sign of this. Okay, let me give you the equality sign also. 1 over here, 2 over here, 3 over here. So it is actually a matrix of 1 comma 3 comma 1 comma 2 comma 3, which is its element. And now put a dot multiply with back over here, and as you can see, we just put a wrong mistake because we want a square now, not a n or a2 a3. Okay, so we will just got element by element whack over here, and here you can see that it is 0.1 to the power 1, 0.1 to the power 2, and 0.1 to the power 3 will look like 0.1.1 and 0.0.1, 0.0010 over here. Let's try to implement the second command of array which we use going to use over here, which is comprod actually. And here you can see comprod is element by element in multiplication. So what the first term will be, it remains the same. First is first. The second term is multiplication of first term and the second term of vector, which is 1 multiplied by 2, basically 2. The second term stands for 2. What would be the third term? The third term will multiply by 1, multiply with 2, multiply with 3, which is basically 3. Oh, sorry, 6. So the third term will get us is 6. Let us also do some comprod of 1 canon 5. Okay, so the we have just if we want to the answer of this particular raw vector actually of 5 terms. So first term will be 1, second term will be 1 multiplied by 2, 2, third term 1 multiplied by 2 multiplied by 3, 6. It will basically give us also a factorial of each particular element. So 1 factorial is 1, 2 factorial is 2 factorial is 2, 3 factorial is 1 multiplied by 2 multiplied by 3, which is basically 6. 4 factorial is 4 multiplied by 2 multiplied by 1, 24, and 5 factorial is 124. So it will give us the one row vector of comprod. Okay, clear the screen. So this is how we going to do call the edit. So yeah, at here we have to define the and, we have defined the and, we have defined a for a, and we have defined all out the computation we had made through our questions. So first of all, in this lecture we will basically do um, some practice with the truncation error on the Taylor series. Taylor series will just look like this, like it has the function f of x plus h is equals to fx plus h multiplied with f dash x plus h square over 2 factorial multiplied with h double dash x, so and so on. The n term for this is equals to h raised to power n over n factorial multiplied with function f of nth order with x. At this last, but this is the last terms of this series, which shows the error of that particular series of the given order. As you all of us know that the Taylor series is used to derive the numerous methods of computational techniques. The above series is stand for n terms, so the error will be order of n plus 1 order of h raised to power n plus 1, because we have the order of n, so the error will be increased by 1. Okay. You can see that numerical mathematics techniques, you can also go for the link provided you between the NPTEL courses. So you can go for numerical techniques if you want interested to know how the Taylor series works for the um, used to computational techniques. The accuracy of this series of is depend upon the how many terms you use to derive the numerical scheme, or you to use to derive the numerical techniques. um, Larger number of elements or larger number of terms will reduce the error, but it will increase the order of that particular error. As you know, if the series is for stands for n term, the order of that particular error will got increased by n plus 1, but the error which is in Taylor series stand for h will be reduced. So in that lecture, we will go for our previously do we will go for a previously done module which was on for Maclaurin series expansion for e raised to power x. Sorry, it's not e raised to power x, it is e raised to power a. So Maclaurin series expansion until e raised to power a is like e raised to power a is equals to 1 plus a, which is first order, plus the second order a square over 2 factorial plus a cube over 3 factorial, and so on to the a raised to power n upon n factorial. And this is how the error will look, or the representative the error. Okay. So the last term implies error in retaining only finite number of terms of the series. So the last term, which is like that, it is this error, implies the error in retaining only finite number of terms. If we, and in this particular series, we have n number of finite terms. Okay. So let us go back to the series which we have done before, which was Maclaurin series, as you know. So, as you all know, the Maclaurin series has, we can also compute the Maclaurin series coefficients with the new way, which is which we can use for the power of MATLAB of array. So we can also use that particular method to compute the Maclaurin series. Let us compute this with the new one. Okay, so this is not an actual we have done before. It we just erase some data on. Let us try to do put a new power, or give it to a new power of computing. So let us define a VAC series, which is VAC is equals to 1 quinone n, and that n particular next define a terms is equal to, we have a multiplier, and it is a dot caret vac. Then uh, this term will
the power of arrays in order to do that.
So this particular term will give me a square a1 a2 by an, okay, and we have multiplied the 1 upon n factorial also. So we will also define it by with each particular element by element subdivision. So we put a dot over here and then vac vac it here, okay. So we put a vac over here